Hello guys, welcome to Amazing Engineering, and today in this Inventor tutorial we will set the analysis of a simple frame. As first we have to create the frame skeleton, so let's create a sketch, for example on the XY plane. Every time you are making a frame, the dimensions of the lines have to be on the order of meters. So let's create a line, for example, which is 3000 millimeters length, another one which is 6000 millimeters length, and other two lines which are 3000 millimeters length too. Let's save the part. We can call it, for example, frame skeleton. Now let's create a new assembly. Open the frame skeleton. Now click on Insert Frame. Before this we have to save the assembly. We can call it, for example, IFA, so Inventor Frame Analysis. Now we have to set the type of beam to use for the frame, for example a simple ANSI beam. Select the dimension, the type of material to use, then select the line, you can change the offset of the beam using these points or simply setting the offset distance, and you can also set the angle between the axis of the beam and the line. Select the other lines, click on OK. We can also link these beams using the command right angle. And now we can start the frame analysis. So click on IFA, New Simulation, Static Analysis. As you can see, Inventor set the number of nodes on the frame and the gravity force. Because during a frame analysis the gravity force is not considered, we can suppress the gravity force. Now you can see the properties of the frame, for example the section, the volume and the moment of inertia along the different direction. Now we have to set the constraint of the simulation. We can choose a simple joint, a spherical constraint which blocks the displacements along the three directions, a cylindrical constraint which blocks the displacement along a specific direction, or you can create your own constraint. But for our case we will use a simple joint. So let's set the joint on these 3 nodes. Now we have to set the loads, for example, a force on this line, we will use a force of 1500 Newton. You can also use the components of the vector of the force vector, so we can set 1500 Newton along x direction. You can also change the position of the force using the offset. So the offset is these nodes, and we can set, for example, a distance of 1000 millimeters. Now we can set a distribution load on this line. Again, you can use the component of the load vector. For example, we can set minus 2000 Newton per millimeters along the y direction. And again, you can choose both the offset and the length of the load. The offset is this node, so we can set, for example, as length 1000 millimeters and as offset distance 2000 millimeters. We can also set a moment on this line, for example, whose value is, for example, 10,000 Newton per millimeters. In IFA settings, we can set the colors of the loads, constraints, nodes, and something else, and the type of diagrams to use. Now let's start the simulation. These are the results displacements on the frame. We can also watch the forces along different 3 directions, moments along the different direction, and both the shear stresses, principal stresses, and torque stresses. We can also watch the diagram of forces, moments, and stresses along different lines. For example, we can set this line, and this is the diagram of the force along x direction, y direction, and z direction. We can do the same for the moments and the stresses. We can also animate the simulation. And clicking on diagram, we can see the diagram of the forces, moment and stresses on the frame. For example, this is the force along the x direction, this is the force along y direction, the force along z direction, and we can do the same for the other properties. Well, this is all for today. I invite you to subscribe on my channel and see you for the next video.